Well, hello friends. Welcome back to browser hacking. Today we are going to look at the performance of the Canvas cycle demo that I worked on in the previous browser hacking video. So just to bring you up to speed, in the last video we made this demo work in the browser, and since then I have fixed the color issue we had. So previously it would render in sort of a bluish greenish way, and that's because the blue and red channels were not matched correctly between the web canvas implementation and our graphics driver. So all that stuff is working now, and today the goal is basically to profile this demo and try to improve performance and see if we can get a smoother animation. So for reference, here is the same demo running in Firefox. So you can see here that it is quite fluid in Firefox, and we are not very fluid indeed. And we have this debug logging here that shows how long every frame took to render in milliseconds. And this just gives us a number to target. So we're going to try to bring this down as much as possible. Of course, the dream would be to get down to 16 milliseconds, which would allow us to hit 60 FPS. But I'm not sure if that's realistic. We'll see what we can do, basically. Anyway, so actually, the first thing we're going to do is get a profile. So should have just left it running. Okay, so we'll profile everything in the system for a bit, and then stop profiling and open the profile viewer. And then we can see here that request animation frame is near the top, which is fine. So basically everything happens in request animation frame callbacks. And the biggest thing here appears to be get function name, which we looked at this profile briefly last time, but we didn't really dig into what was going on. So that's what we're here for today. So we have get function name, double to string, 28%, and fly string constructor, 11%, string builder to string, building a lot of big strings here apparently, almost 11%. So a whole bunch of stuff going on. So we're just going to start at the top with the first thing that is suspicious, and that's definitely get function names. We have 30% of samples within JS get function name, and get function name. What is that? Okay, so this generates a string given a value, and get function name. A little bit confused what this is for. Okay, so it's used by class expression. When we execute a class expression, we use get function name to come up with the names for the getter and setter. Okay. And then when we execute a assignment expression, then we use get function name to update the function name of the right-hand side result of every assignment for some reason. And then we use it in object expression execute. What's that? Get function name. Okay, so again for getters and setters. Okay, so it's computing a function name for something and then passing it to update function name, which makes a hash table of visited things so that we don't visit the same thing multiple times, I guess. And then update function name ignores non-object values and then ignores already visited objects. And then for function objects, we check if the function has an empty name, and if so, we set the name of the function to the name. Okay, and for array objects, we iterate through all of the indexed properties in the array and call update function name on those. And what is this used for? So the fact that we're doing it in every assignment is extremely suspicious to me. Because why do you need to compute a function name whenever you're assigning something? That's really weird. So let's do a quick. How do you get blame in C-line? I gotta learn that kind of stuff. So current file, can you annotate with get blame? Yes. Okay, so wait. But I want to go to the thing before that. Annotate previous revision, okay? So these are like refactorings and more refactorings. So I'm just going through previous revisions until we get something that looks like the original. Okay, so here. Set name of anonymous functions during assignment. Wow, this UI is kind of strange. Okay, that's the whole message. I'm not used to using C-line for looking at commits, but we're trying it out. Okay, so set name of anonymous function during assignment, and it touched these files. It added update function name, and then added calls to it. Sure. So set name of anonymous functions during assignments. What does that mean? It means that when you're assigning anything, then oh wait. Oh, I get it. So it's let's bring up the REPL. So it's when you do something like foo is function like this, right? Then the function object that is constructed here actually has the name foo. So foo.name is foo. Even though nothing in the expression on the right-hand side actually has foo in it, because it was assigned to an identifier on the left-hand side that's foo, that means that the name foo magically transfers to the created function. That's a really weird behavior. And then we do that for arrays as well. So, I mean, it kind of makes sense for functions, but what the hell is the array thing? So, if you make an array of, I guess, like functions like this, right? Then they will all be named A. That's so weird. That's so weird. And let's test this out with V8. So if we do this, yeah, right. So V8 does the same thing. Does it do that with the array thing though? Because the array thing is so weird. Yeah, it doesn't do that. So why do we do that if V8 doesn't do that? Let's test JavaScript core. Okay, yeah, so it works on that one, but what about the array thing? So neither V8 nor JavaScript core does this. So I wonder why we're doing that. Let's let's check Firefox while we're here. So foo is function like that. Sure, gets the name foo. Oh, all right. So Firefox does this, but V8 and JavaScript core don't do this, but we do that. Well, that's weird. Because I feel like this is kind of complicated. Because of the array case, right? Because of the array case, we have to iterate through all of the index properties and the value, and recursively call update function name on them. But if we didn't have to do that, this whole mechanism here would just be a lot simpler. So I guess let's look at the spec, see if we can work out what we're supposed to be doing. Take me to the thing. Oh, so what is this? This is like runtime semantics for the assignment expression. So one of these unhelpfully named things. I guess we just have to click through them until we can find it. Because I want the one for assignment expression. Okay. Oh, wait. Here. Okay. Runtime semantics evaluation of assignment expression, left-hand side expression equals, or assign assignment expression. Right. Okay, so if left-hand side is neither an object literal nor an array literal, then blah, blah, blah. And okay, here. If is anonymous function definition assignment expression. So the right-hand side is an anonymous function definition. That's our case. And is identifier ref of left-hand side expression are both true. So this should only happen if the right-hand side is anonymous function definition and left-hand side is an identifier. I think. At least assignment expression. I don't see anything about arrays of functions here. So well, let's see what this is. Is anonymous function definition determines if its argument is a function definition that does not bind a name. So it's the result of parsing an assignment expression or initializer. Yeah, so without going too deep, I think that we have basically implemented a Firefox specific behavior here. And neither the spec, V8, or JavaScript core implement this behavior, so I think it's safe to get rid of it. So let's do that. So let's see. So the array case disappears. And update function name. Then we don't need the visited mechanism. And then we can actually just yoink everything into here. And we don't need the git annotation. How do I get rid of that? There we go. And we only care if the right hand side is a as an anonymous function definition, right? So it has to be a function, and indeed the name has to be empty. So we can actually check here. If it's not a function, then we don't care. And do that. Value, do we have as function? We do have as function. Loop. Yeah. Yeah, that seems better, because then at least we don't need to recurse through arrays. Because previously we would, like, whenever you would assign an array to something, we would have to recursively visit every part of that array and call update function name on it. So we get rid of that, but we're still doing this unconditionally, even when the right hand side is not a function. So let's see, update function name, blah blah blah, class constructor value. Okay, yeah, right. So he will just return actually if it's not a function, so that's good. And same thing here. But this one though, so this one is a bit nasty because, so this is the assignment expression, and here we will always call get function name even if the right hand side is not a function. So I think here, what if we just do this? Because if it's not a function, then we shouldn't waste time coming up with a name for the function. It's only relevant if the right hand side is a function. And in fact, we should also check that the left hand side is an identifier. So LHS result is identifier. No? Oh, wait. That's not how we... that's not how that works. What is the left-hand side? It's an expression. And identifier... Okay. Inherits expression? Sure. Do we have these type of checks here? Let's see. Let's add a way to check if something is an identifier. Yeah, so here we'll just say virtual bool is identifier const override return true. All right. And this file is making my IDE lag. I think we're gonna just restart the IDE at this point. He seems a little sad. I'm running an early access preview build of CLion to test out some new features, so it's been a little bit sluggish at times. Oh wait, did I do something wrong with that? Maybe it was my fault. expression is identifier. Oh, look at me blaming the IDE. Okay. Right, so the left-hand side is an identifier and the right-hand side is a function. Then we'll do this thing. So let's see if this builds. We're probably going to break some tests, but I think in a situation like this, like it's always complicated when you're building a browser to know what to do in situations where the different user agents or the different browser engines differ in behavior. But in a case like this where you have a majority of the engines and the spec doing one thing and then it's just one user agent doing something different, I think that's fairly straightforward to side with the majority in this case. Okay, so we broke some tests. Functions, function name.js. Sounds like exactly the type of test we would break with this type of change. So can I open that here? Yes, I can. And let's see, functions in array assigned to variable. Yeah, indeed. Okay, yeah, so it's testing for exactly this thing right here. We're just gonna, I guess we will just do that, or to be, do we have to be undefined, right? Or wait, name isn't going to be undefined. What is the name of a function like that? Oh, it's the empty string. All right, so I had the right idea. So instead of removing the test, we'll just update it to match the behavior that we're switching to. Functions in array assigned to variable, functions in objects. Okay, hold on now. That one though. Wait, did I break that one? Cyclic members should not cause infinite recursion. So that's like a weird array case. I guess that's what the visited set was for, to prevent like infinite recursion if you have like a self-referencing array or something, but that's a special case that we don't need to care about. So we'll just yoink that and throw it out. But we still have the functions and objects case, which we shouldn't be breaking, I think. Functions in objects. Expected C got empty string. O.C. Oh, yo. Is this the identifier check that we're screwing up here? Is identifier ref? Oh, I think I misunderstood what that was checking. Identifier reference. So it's not just for it's not just for this, but like if you have a reference. So this is a member expression with a non-computed property name. So the property name is an identifier, and that identifier, I don't think we have a straightforward way to test for this case right now. So actually, let's get rid of this change, and we will leave this as a fix me because we don't have a way to test if the left-hand side is a let's see, so we have turned it into a reference. Okay, I don't think we have a way to check if a reference is an identifier. Yeah, so I'm gonna put a fix me about this instead. Fix me should also check if the LHS is an identifier ref. Yeah. Okay. That will require some more work on the reference implementation. Okay, so we are good test-wise. Let's see how much this might do for the frame time. Okay, so we are down from what? We were previously in the 240s, 250s or something? Oh, did I not keep that? Oh, here. Yeah. So 230, 240, yeah, 2 something, down in the 1110 range, almost sometimes even going 100 milliseconds for a single frame. Just a very, very nice improvement. So let's get a new profile and see where we're at. So and of course, let's see if it looks fluid. It's still not enough to look totally fluid, which is, to be expected because we're in the, I guess, around 10 FPS, right? So obviously that's not enough for smooth animation, but it's a nice improvement. So we'll profile all processes for a bit and then stop profiling. Oopsie. Okay, so request animation frame near the top, sure. And now what are we looking at? So get function name is totally gone, obviously, which is great. That's where all the performance was disappearing. So what else is new? Member expression execute. So this would be a bracketed property access with a computed property name. Very popular. Probably indexing into some kind of array object or something. Reference put, so that's assigning something to a local variable in a function, presumably. That's what we're hitting here. We also see uint8 clamped array put by index. So uint8 clamped array is a kind of a strange special array class that's used in JavaScript specifically for canvas element image data objects. So it has a slightly different behavior from normal typed arrays in that if you assign a number above 255 to a uint8 clamped array element, then instead of wrapping that number like a typed array would, it will like saturate it at 255, right? So it will never be above 255. If you assign 256, you get 255. That's what that array does. So it's a bit weird. Okay, so we have array lookup. Variable lookup. 10%. That's pretty heavy. It's gonna take. Variable lookup in LibJS is not optimized at all. So whenever you access a global variable, for example, if you're in a deeply nested lexical scope, then you actually have to traverse all of the lexical scopes until you get to the global scope, and that's where you find your variable. So we waste a lot of time just traversing lexical scopes and looking for variables. That's something we could definitely optimize, but it will require some architectural changes. And I guess today I'm more looking for kind of smaller, big bang for the buck type changes. Okay. So what else do we have? We have JS value to numeric, 5.5%. JS add. So like adding numbers together, that is definitely, we don't have a fast path for that at all. So this is probably something we could improve. I would think. And then what is this? Enter node. Enter node? Wait. 5% in enter node. Enter node is, it's this thing that just keeps track of which AST node we're currently executing. But it's just adding them to a vector. And then like popping them off the end of the vector when we exit that node. So it's like an AST node stack. But we spent 5% of runtime updating that node stack. That's a bit too much. We can definitely improve that. Maybe a vector is just not the right data structure. We could do like a linked list of like stack. We put like everybody would put something on the stack when they execute, and then we would link all those things together, and then we would not do any heap allocations or vector manipulation at all. That might be a much better option. I think we should be able to get rid of this almost completely, I would think. And then we have 2i32. It's kind of heavy. Converting a value to a 32-bit integer. Calling fmod. Oh, shit. So JavaScript engine values at the moment, if they are, they can have a bunch of different internal types, but for numeric values, they're always just number, and number is just a double precision floating point number. So even if something is an integer, we still store it as a double in our union here. And that's definitely something that we could improve by having like something like this, right? And then having a special type for known integers. And then that would allow us to, well, we wouldn't have to use like libm fmod to convert that double to an i32 if we already know it's an i32, right? There's probably a lot we can win from doing that. Wait, this looks totally useless. This is a tiny function. Why is this here? Cell VM. Oh, because it's out of line. Okay, yeah, so we should move these so they can be inlined. Because they're just looking up the VM from a cell pointer, and that happens everywhere all the time, and there's no reason for that to be out of line. And even, I mean, if you look here at the per instruction breakdown of samples, you can see that just on function entry and function exit, we have like more than a third of the samples are in entry and exit. That's usually a pretty good indication that something is suitable for inlining. If you have like a tiny function like this and a third of your samples are entering and exiting the function and it's not virtual, definitely something to look into inlining, because inlining this will definitely get rid of the entry exit stuff, but it will also most likely unlock additional inlining and optimization opportunities at the various call sites. So we're going to do that for sure, but let's commit actually before we get ahead of ourselves. So this, blah, 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 not that. Speaking of getting ahead of ourselves. Okay. So LibJS. Only assign, only update function names. Only update anonymous function names. Wait, how did we describe that? Change when necessary. Previously, we would update, generate function names for anonymous functions on every assignment expression, even if we were not assigning an anonymous function. Not even, I guess we can say a function, or let's contract here to keep the column size correct. Okay. This we were also setting names of functions in anonymous functions in arrays, which is a what is their engine called? SpiderMonkey, which is apparently a SpiderMonkey specific behavior, not supported by V8, JSC, or required by ECMA 262. Since it was making, since this patch also removes that behavior. Yes, okay, so this is a huge performance improvement on the Canvas cycle demo. Cool. All right, and then let's just inline those things. So we'll just, I guess we can't put them in cell.h because it doesn't really include anything from LibJS, but we can put them in vm.h, which is nice because everybody includes vm.h also, so we don't have to run around and mess with that. I mean, there's probably somebody who's going to complain about this, because whenever you try to inline something, there's always somebody who's who doesn't include that header. And today's winner is wait, how do I read this? Undefined. Oh, okay, here. Handle CPP. LibJS runtime VM. It's just build JS only. Yeah, so we were in the 110-ish range before this last change. So, but it wasn't super heavy, right? Like it was 2-3% or something like that. But even that is crazy for something that is trivially inlined and, as we talked about, like has a third of samples hitting the entry and exit instructions. So I think this would offer a small but solid performance improvement. But we'll see. Let's test it out. Okay, so we're still around that same area, although we are definitely getting more sub 100 frames. So slight improvement, not huge, but slight, which is to be expected. So cool. Let's just commit this, not you. LibJS, always inline cell, VM and cell heap. Okay. Then I wanted to look at was enter node and then making the value object have a dedicated type for i32. So let's see. That one is a bit harder. So let's do the enter node thing first. Value.h. I should get rid of this so I don't accidentally commit it. Enter node. Okay, so right. So what we do here is we just push the current node to the vector of AST nodes in the interpreter. And this is done as we're traversing the AST by this thing called the interpreter node scope, which is an RAII helper that simply calls enter node on entry and exit node on destruction. And then we instantiate these in every execute handler on every AST node. So whenever you execute an AST node, we instantiate one of these to enter and exit the node. Pretty basic stuff. So here, what if we could chain these together? Since we have them on the stack anyway, we could do something like if we make a struct here like AST node chain, something like that. Executing AST node chain, and we link to the previous one. So we're going to make a linked list on the stack, which is it's a trick I find it really charming in a way, making lists of things on the stack or linking together stack things when you have these deeply nested control flow. Very, very neat trick. So I guess we'll just put the node here like that, and then push AST node would instead be something like, or wait, how do we do this? Current node, that would have to be, okay, this thing has to change to executing AST node chain, sure. So that will be the currently executing AST node, and then there's a backwards linked list of all of the nodes that led to that one. No, it's not led to that one. It's like in the tree hierarchically. I don't know how to express it. Like if one node calls another function, then that creates a new level in that list, I guess. So anyway, if not AST node chain, then we don't have a current node. Otherwise, just return that node, right? Actually, yeah, it's just like that. Node stack. Yeah, so we can't return this, but we can give you the executing AST node chain. Executing AST node chain. Sure, no big deal. I don't know if we need a const or a non-const version. Okay, and then when you want to push something to this thing, you really have to push one of these things. Chain node, let's say. And then chain node. Previous is our current AST node chain, and then you become the new one. Sure, and then when we pop, then I guess we will verify that we actually have one, just to be double sure, and then go backwards. Okay. Right. And then in the AST interpreter node scope thing, instead of storing the node like this, we can just make an executing AST node chain node thing. Right, so this goes on the stack now, and chain node. So that's the previous and the node. You don't like this because wait, oh, we have to call enter node. Do we need these functions? Nobody else calls them. Maybe we don't need them. What if we just integrate that stuff here? So like that, and call frame current node is node, and push AST node chain node, right? Is not it? Oh, no, okay, there we go. Syntax highlighting takes forever sometimes. Node stack. Right, oh, right, yeah, right. So somebody was using these APIs that we just removed or renamed. Okay, so exception. The exception class accesses the node stack and then walks it backwards, adding to source ranges. Sure, so we can just do this. If auto executing node chain. Maybe just node chain. Executing AST node chain. Or can we even do this? Node chain is node chain previous. Ploop. Ploop, ploop. Node chain, node dot. Cool, okay. That's lucky that it was traversing it backwards anyway. Since that's exactly what we needed, or our new data structure just happens to be backwards anyway. Okay, so exit node is still being called somewhere. Sequence expression execute. I guess I just forgot to use the nodes interpreter node scope helper thing here. So previously every AST node execute function would do exactly this, and then I added this little helper that does that. So I guess I forgot this one place here. No big deal. Should have run the tests actually. Okay, no tests broke from that. That's cool. And now we are definitely seeing majority sub 100. Some in the 80s even. Very cool. Okay, all right. So I would say that's a nice improvement. Let's get a profile and see what we're looking at. Yeah, so I guess it was just appending and removing from the end of that vector is a bunch slower than doing this, like just linking these stack structs together, which kind of makes sense, I guess, because you don't have to do any vector operations. Although it's a little bit weird. But since the number is improving, let's not waste too much time questioning that. Okay, so top functions, and what are we looking at now? Value to numeric is like it's like a goofy thing. But enter node obviously has disappeared, and we don't see interpreter node scope anywhere. No, that's good. Maybe I should add a search function to this thing, or a filter or something. Right now I'm kind of just eyeballing. Enter scope. Yeah, that one is heavy because I have to set up all the local variables in the scope and stuff. I got it confused with enter node at first, but it's not the same thing at all. Update expression execute. That's like a plus plus I or I plus plus, right? That's an update expression, usually something like that, which it looks depressingly heavy. Wonder if it's doing something unusually stupid, like it's only generating the reference once at least. Yeah. But I think, oh, that's a bit unfortunate. So like, if you do I++, then first we have to fetch I, which goes through variable lookup, which has to iterate through all of the lexical scopes, and then we have to write the new result of ++ing I, and then we do another variable lookup, traversing all the lexical scopes and stuff. So you can see here that it hits VM set variable, which is where all the scope traversal happens. So I++ does double lexical scope traversal. That's really sad. But I don't really want to get into re-architecting that at the moment, so let's instead look at stuff like 2i32. So that one, I don't like that one. We should have some kind of a fast path for values that are actually i32. And also this one is really weird. Like, why are we seeing so many fly string from act string conversions? So can we maybe, like, let's invert the profile so we can actually see it here, and then we can find out who calls it. So it's VM get reference calling it. And reference put, reference get. Get reference. This one calls fly string with act string argument. So I guess it's these two. Constructing a reference. Second argument is name. Wait, so there's no tag, or is, oh no, there's local variable and global variable tags. Oh, okay. This is one of these two constructors here, and both of them take string. Oh, wait. Fly string from string. Okay. So they take string, and then mname is a property name. A property name takes a string and immediately converts it to a fly string. So probably this is the conversion that we're seeing, this implicit thing here. But I wonder, are we just doing some pointless conversion here? What is name? Name, so look here, name is a fly string, and then we're forcing it to become a regular string, and then immediately turning around and converting that regular string to a fly string again. And all that happens just because these take regular string instead of fly string, because if we take fly string here, forward that to property name constructor, then property name constructor already has a fly string variant. So I think this should be fine to just do that. But let's see if it compiles now. Yeah, so that was probably just a completely unnecessary thing. I mean, it wasn't that big of a deal, but it's still nice to get rid of that kind of stuff. Let's see if it fixes it. So it still works. So up top now, no more fly string from string constructor, although we do have fly string destructors, but that's a whole other story. The fact that we have a lot of time in fly string destructor is, you know, unfortunate, but at least we're not constructing them unnecessarily. That's actually really cool. Wait, interpreter VM? Why is that 1.58%? Interpreter VM, that's a tiny function. That's an incredibly tiny function. These should be always in line then. And this, what are you doing? It's just always in line, these boys. Yeah. Okay, so let's see here. Which one do we do first? I guess the let's do the reference thing first because that was so small. LibJS. Void unnecessary fly string churn in reference ctor. Constructor, we don't have space for that. Okay. Yeah. Okay, and then let's do the node chain thing. I actually kind of like that solution that we have for that. It's very nifty. Don't use a vector for. Don't track executing AST nodes in a vector. Instead, just link together the interpreter node scope and walk in a linked list and walk the list backwards if necessary. Or, yeah, no, like that. This was surprisingly hot on Canvas cycle. And then, yeah, so let's just always inline these. Always inline some tiny interpreter getters. Yeah. Oh, enter node and exit node. I didn't delete those functions. This is going to be a fix-up for something. Fix-up for something. It's for which one? I guess this one. No, not that one, this one. Okay. All right, now we can attack the value thing. So let's add an i32 mode for JS value. And this will be big enough change to change the copyright, I think. So we're gonna expand number or split number into n32 and double. And then isNumber has to check if type is n32 or nType is type double, because now both of those are number. And we have as double. Okay, so I think we'll make it do this. Is verify that it is number, and then this will transparently convert for you if needed. So like that. And then the constructor. Okay, so we already have a convenient constructor right here. That will now do this as i32. For unsigned, oh, that's interesting because it could be too large. So we have to branch actually. If it's too large, then it's a double. Type is type double. Else, we use an i32. Cool. And for double, you can just go to double. Although I wonder, this is a bit annoying. I guess I was thinking, like, should we check here if it could be an i32 and then use that instead? So if we don't do that, if we do that, then we incur the cost of conversion on every instantiation of a value from double. But if we don't do that, then we risk ending up with a bunch of double values anyway. Let's not do that at first, and then we'll see how this works out. That's fine. So static cast i32. So where can we take advantage of this? 2i32, for example. Also, this thing should really have something more like a slow case out of line. So if mType is type n32, in that case, we can just return it, right? Otherwise, we have to return i32's load case. And we'll put that out of line. Because in many cases, we will just have an i32 ready to go. So let's see, const, I guess. And we need to rename this boy right here to that. Okay. Let's verify that type is not. And most numbers will come into this world, I think, from numeric literals originally. So numeric literal. You execute a numeric literal AST node, and we will produce a value with this thing inside of it. So I guess what we could do here is just store a value like this, and then give you that. And then we would only need to figure out if it's a double or an I32 once when we parse. But we should probably move this out of line then, so we'll put this. Okay, double value, sure. And then if value is within numeric, not numeric limits, I32. Min and value less than or equal to numeric limits, I32 max, and then M value is a value of I32 value, right? Something like this. M value is value. Okay, IDE error occurred. Let's report. Let's be good boys. Also, what is this? You're complaining about a trivially copyable type. Sure. 732. Oh, yeah, right. We have to go and clean all of this up. So this is unary expression execute. Just figuring out the type of. Okay, so in that case, like, this is fine. Oh, and then in value CPP, there's going to be a lot of checks. So let's just go through them. So this one, actually, we can improve quite a bit. This is toString without side effects. So we don't have to do double to string conversion. If we know that it is a I32, then we can simply use string number. That's nice. Definitely cheaper than double to string conversion, which is very chunky. Type int32. Wait, where was I just? Oh, this is toString with side effects, of course. Sure. What else? Yeah, and then the I32 case here doesn't have nan because int32s don't have a nan state. What am I doing? What is this? To Boolean, right? Right. So when you're doing a to-object, I think in those cases we can let's do this. Okay, blah, blah, blah. This one is value to number. Wait, so if we're an int32 or a double, we can just return a value, no? Or we can just return this. Just return self. You are already a number. No need to get fancy. And this is too big int. Some exception case here. It's fine. So I suspect that this will probably work, but the main issue is that we don't really propagate the i32 state very much. So like the moment you do any kind of math, like adding or subtracting or something, the result will become a double, and now you have doubles instead of i32s. So to really get the benefits of having this type, we would need to make all of the various math code detect that, like, oh, you're adding together two 32-bit integers. Can the result be represented by a 32-bit integer? If so, produce that as a result rather than producing a double as a result. And that's probably a pretty substantial change, but let's run tests. Okay, stuff broke, sure. Expected 3 got 3, that's very suspicious. It almost feels like we broke equality checks. EQ, strict EQ, checks type. Right, so that doesn't work anymore because now we have i32 and double, which are identical types for equality checking purposes. So if same type for equality, let's invent something like that, and then static inline bool, same type for equality. And then like, actually let's do this. If LHS type equal RHS type, return true. If LHS is number and RHS is number, return true, otherwise return false. Yeah, and then the compiler can go to town on actually optimizing this. Because I'm sure that there's some fancy schmancy way to express this with some bit checks or whatever. But let's see. Oh, I bet we have a bunch of these. So like type let's just search for something like this. Type, no. Oh, this is what I'm kind of after. Yeah. So what do we want to search for, actually? Like something like that. Same. This needs to go higher up, I think. So yes, here we go. Same type for equality. Okay. Let's see if that does the trick. Ah, okay. Good. So, yeah, so as I was saying, I think probably not going to see much improvement from this. Just because, I mean, we'll probably still see the conversions, that's what I mean. I did see a 7. Yeah, we have some 7s here, that's really cool. Dipping into the 7s. But let's take a look at profile, see if the to I32 conversion is still showing up much, and then see if we can do something about it. To I32 slow case, 4%, still in there. Calling fmod, calling trunk. Okay, so it calls trunk in the leaf. Let's flip it upside down and look for a trunk. See who actually does this. Yeah, okay, so it's uint clamped array put by index. Uint a clamped array put by index, right here. Okay. So we have like some array and we're doing this. We have like a U32 property in X, so like this is essentially something like this, some value, right? And our value has to be converted to an I32, but it's currently not an I32, it's a double. We don't know where it became a double. Okay, let's try the lazy approach first, where we simply we can simply do this here in the constructor when you pass a double. So kind of what we did in the numeric literal, actually. This stuff. As I32. Yeah, so this is not optimal. I think optimal would be to make sure that we always produce the right type. But this could be good still. As double, yeah. Okay, yeah, and then we don't actually need, or no, we can leave it like this. This is okay. It's a big rebuild, but it's okay. Yeah, so basically now, whenever you construct a JavaScript value from a double, which is what you'll get from every add, subtract, multiply, divide, whatever, all of those will produce doubles, and then call this constructor, then we will try right away to jam it into an I32 value instead. And the result of this is that we'll have a lot more I32 values, and hopefully that is what we'll end up passing to uint 8 clamped array put by index, which then won't have to do a double to int 32 conversion. But we'll see. Yeah, this change, I feel a little bit like this one is a little bit messy because it's not immediately obvious to me how to, like, which parts of the code need to specialize for this case, but Okay, well, this really didn't work out. Although that may have been something temporary. I don't know what that was. Okay. That's a little weird. So, nothing spectacular showing up in the profile. Rather in the frame times. We're still in the 8s. With a sprinkle of 7s every now and then. But let's see if we still have a bunch of trunk. We don't. So at least that is something. And can we find the uint 8 clamped array? No. JS value as I32. That's suspiciously much. 1.34%. It could probably be inlined. I guess it's out of line for some reason. Less than. Two numeric. That's weird. So this looks like it's. Add. Okay, so we're adding numbers together. This seems to be the biggest math thing that we're doing here. And add has to turn the arguments into numbers, which requires a bunch of calls. But what if you already know that you're adding together two numbers? I feel like we can short circuit that probably. It would be in this file somewhere. Add, right here. Yeah. So we come into add to add together two numbers, but first we have to convert them to primitive types, and then we have to convert those primitive types to numeric, blah, blah, blah. How can we make this better? Too primitive. Let's see, so too primitive, it's already primitive if it's a number. So this one is just very heavy, sure. Too primitive. Also, there's a lot of calls to global object BM here, which is not the cheapest. Okay, wait, let's commit before we get into add. Yeah, I think we'll do this one as we did. And then there's probably improvements that can be made. At least we do, we apparently do less double to int conversion now. So that's at least nice. And I want to expand on this because I know it to be a good optimization thing, because like it's this kind of thing that all engines do. So I already know from experience that this is a useful thing. It's just we're not really fleshing it out as much as we should here. So it'll be something to give us more opportunities going forward. Split value type number into int32 and double. This allows we now store 32-bit integers as 32-bit integers directly, which avoids having to convert them from doubles when they're only used as 32-bit integers anyway. This patch feels a bit incomplete, and there's a lot of opportunities to take advantage of this information. We'll have to find and exploit them. eventually. Okay, so let's look at this add business. Okay, so this thing irritates me, so I'm just gonna do this. Global object VM and do. Oh wait, that's not what I wanted to do. I wanted to do this. Oh wait, let's do multi-cursor. Gotta get better at that. Okay, so doop, 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 doop. Wait, I didn't do it right. Dang it. Okay. Oh, wait, shit, it's not actually placing my multi-cursor. Okay, well, whatever. I'm not gonna cry about it now. I guess something in this early access preview build is different than what I knew from before, so ignoring that. We also don't need to get the heap that way. We can do VM heap. VM heap. Okay, this was totally gratuitous. I'm just I mean, it's not gratuitous. This will reduce the function size for sure, but I'm just gonna do this as a separate commit because it was annoying to me. Call global object VM once and add. Yeah. Okay, so if we know that we have two numbers coming in here, we could skip all the way down, go all the way down here, both number, right? So, and just go straight to this thing right here, which adds together the two doubles. The problem with add is that it makes all these expensive calls. Like 2 primitive is expensive, 2 numeric is expensive. So we can't hoist this because you may convert something else into numbers, but we can definitely do a fast path up here. Just this, right? And I guess here's an opportunity to avoid a conversion that we talked about. So you could do something like if LHS value type in 32 and RHS type value type in 32. Then, in this special case, we make a checked for the result, and then result is LHS to I32 global object, because this will take the fast path we already know. And we plus equals to I32 global object. And then if there was no overflow here, then we can simply return that. So this is a super fast path. I think this type of fast path is definitely worth having in a JS engine. You definitely want to make the most basic math as fast as possible. And since like what we have right now is an interpreter architecture, so this is a typical interpreter fast path. In the future, our fast path's probably going to look quite different from this, but this is the current architecture of the engine. So yeah, I feel like we're seeing a bit more sevens here. That's good. Profile a bit. Oh, we broke some stuff though. Yeah, we got to look at that. Okay, so let's see. Numeric is still here. I don't see add though. So who's calling numeric now? Let's turn it upside down. And numeric is called by abstract relation and multiply. Okay, so numeric calls primitive. I guess. Wonder if simply flattening this function would already be a huge improvement, because yeah, I think we're gonna flatten this one. Do we have flatten as a thing? Yeah, we do, right. So flattening means that it's sort of like upside down inlining, that instead of inlining this function, flatten means to inline all of the things that it calls. So it will inline primitive into this function. I think that will be very beneficial, because whenever you're calling this on something that's already a numeric object, then primitive will do nothing. We'll just return this. So all of that function call overhead would go away. I think that would be a good thing. Yeah. Yes. Okay. But we also broke stuff. So that was not good. How did I manage to break stuff? Both are in 32. Plus them together. There's no overflow. Okay, let me see if I wasn't even supposed to hoist or do this early at all for some reason. That would be weird though if both are number. Oh dang, did I break something else then? Okay, when did I break what? That's annoying. Did I forget to run tests at some stage? I guess I did. So broke some basic math. I mean, it's presumably this thing, right? Let's just go back to... Or... No, wait, hold on. Let's be disciplined. So... Assuming that this is fine, then our fast path is still okay. LibJS. And with two numeric JS values. Flatten value to numeric. Basic idea here is to inline to primitive to get rid of the function call overhead. Okay, and then foo bar. It already exists. Dang. Okay, so dang is where we were, and then let's just go back to here maybe. See where we broke it. Actually, we only need to build test.js. Okay. I wonder if that one actually, the tiny change I made in the consolidating all of those global object VM calls, if that broke something, I'm gonna feel silly. No, it wasn't that. Okay. Dang it. So it was splitting the thing. Okay, well, let's bring ourselves back here, and then we can maybe figure out why things are broken. So numeric literal. We don't need to do that in numeric literal anymore, actually. So m value should just be this. Of course, that's because we already moved that to that constructor. And then this doesn't need to be out of line either. But outside of that, we're good. So that's just a simplification. It doesn't actually change that stuff. Yeah. I32 fix up. Okay, so how did we mess this up then? Same type for equality. This doesn't feel broken. That seems fine. Maybe we should just look at those tests that are breaking. So we have math.sign.js, which sounds simple. Oh, wait, are we doing some screwy thing here where we screw up the positive versus negative 0 or something like that? Oh, dang it. I didn't mean to close those. Yeah, this might be that actually. Okay, so it's probably that new constructor that I added. This thing right here. Yeah, maybe this wasn't good enough. Okay, so I guess we need to do the strict conversion. So where's that fmod thing? Fmod. No, what's the thing I want to do? Trunk, is it? Right, so that's what I want to check. So if I truncate the decimals off of the double, and it's still identical to what it was before, then it's fine to store it as an i32. Yeah, I thought I could get away with just static casting it to i32, but it's not. I think that's not strong enough because JavaScript, in its infinite wisdom, separates these things. So 0 and -0 are different. I suppose actually we could check explicitly for -0, but this just somehow this just feels better to do here anyway. Of course, if this turns out to not be the problem, then I'm just talking out of my ass. But we'll see. I suspect this is going to be it. That was not it. Cool. Did I do any other static cast like that? Static cast? Okay. I'm just gonna do this here just to check, because now I'm very suspicious of this. So those failing tests, does this one have a -0 in it? Yeah, it does have a negative. Okay, yeah, so it is -0, and apparently trunk is not good enough for that. I would have expected that to work, actually. Trunk -0. Trunk. Let's test something real quick here. -0 is that. Trunked is trunk of -0. And then we print out both. Trunked. Return a pleasant 0 and make test. Well, that didn't help me. Can I get more by doing this? Let's see. Neg. Oh, wait, that's an integer. Okay, so in this case, both are negative if I trunk. I wonder if our trunk does that. Yeah, so by the way, the mistake I made here was this, right? So in C++, this is an integer, so the minus will simply be ignored, basically. So I have to do something like that to ensure that it's actually a floating point literal to preserve the sign. Interesting. So test math. We have a math test in Serenity that, well, actually I can't blame test math because it's failing on, it was failing on my host. So trunk value is value. Value is not -0. But this is also it's also an integer literal. It's interesting though, so I'm screwing it up for 0 somehow. If it stores 0 as in int32, then we hit this problem. This implicit construction of int32 values, I guess I don't like it to begin with. Okay. This is a little bit frustrating because I don't really like what we're doing here. But I also don't want to get totally jammed up in figuring out what the best thing to do with this is. So I think, well, so this works, right? Yeah. And for inserenity, we can run the tests and they all pass, sure. And this is good. Also, somehow my machine feels slightly slower. I don't know why. Anyway, we should probably just get a profile here. Okay, in the 8s, some 7s. I mean, there's so many more things that need to be worked on here. Like less than, we can definitely optimize less than. To numeric, this didn't flatten properly? Wait, what? To numeric. I feel like he's not respecting my flattening request. Okay. Multiplication, we can probably also do fast path for numbers. Yeah, there's a whole bunch of little fast paths and things to add, but I think maybe I'm just gonna stop here for today. I don't want to get lost in the weeds now, so we're gonna commit this tweak here. For the -0 to not construct an integer JS value for -0 because it can't store that. Don't try to store -0 as a value type as an int32 JS value. Yeah. Okay. Yeah, I think I'm gonna be done here for today because we've done a whole bunch of good stuff. We got the frame times down from 230 something into the 80s, dipping into the 70s. That's a huge improvement. So what are we looking at here? Say 83, 84. Let's say a comfortable 82 is the current number. And if we use some basic mathematics, then that means we're around 12 frames per second. Certainly not super great, but it's a huge improvement from the 4.3 frames per second that we started with. So about a 3x improvement in FPS today. Very, very nice. And yeah, there's definitely more stuff to do here, but I think we got the biggest, lowest hanging fruit out of the way, so that's good. We're gonna end the video here. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting. I think profiling and optimizing based on profiles is one of my favorite things in programming, so I'm really happy to be able to share it with you all and to do it using using tools that we've made ourselves on software that we made ourselves. Like it's a lot of fun. So yeah, thanks for hanging out, and I'll see you next time. Bye.